In this video, we'll talk about how to solve composite functions. So suppose we have the function f of x is equal to x squared plus x, and suppose we have another function g of x is equal to x plus 5. How could we solve f of g? Well, the way that we would write that is f of g. So we make sure that we write an open circle because this represents the word of. F of g. If this was a closed circle, then that would be f times g, and that's not what we want to do here. So the way that we can rewrite f of g is f with g inside of it, f of g of x. So the way that we solve that is wherever we see an x in this original f of x equation, we're just going to replace it with all of g of x. So instead of writing x squared, we're going to write x plus 5 squared. And then instead of writing plus x, we're going to replace this x with all of g of x. So we'll write plus x plus 5. So that's all we're doing there. And now we just need to simplify. So x plus 5 squared, we can rewrite that as x plus 5 times x plus 5. And then we've got this plus x plus 5 out here at the end still. So let's go ahead and FOIL these two terms. So we'll get x times x, that's x squared. X times 5, that's 5x. 5 times x, that's 5x. And 5 times 5, that's 25. And then we've still got this plus x plus 5 at the end here. So let's combine like terms. So we get x squared plus, we've got a 5x and a 5x, and then we have another x over here. So 5 plus 5 plus 1 more x, that's 11x. Then we've got 25 plus 5, that's 30. So our final answer, f of g is x squared plus 11x plus 30. Now suppose we wanted to solve g of f. So g of f. Well, we can rewrite that as g of f of x. So the way that we do this is instead of writing our original g of x equation, wherever we see an x, we're going to replace it with all of f of x. So instead of x plus 5, we're going to write x squared plus x plus 5. And this one's a little more straightforward. There's nothing to simplify here. So we're just left with x squared plus x plus 5. That is g of f. Now suppose we would want to solve g of g. G of g. Well, we could rewrite that as g of x. And now, wherever we see an x in this g of x equation, we're going to replace it with all of g of x. So instead of writing x plus 5, we're going to write x plus 5 plus 5. And this just simplifies to x plus 5, that's equals x plus 10. So that's g of g. Now what if we wanted to solve f of f? Well, we could rewrite that as f of x. So now whenever we see an x in this original f of x equation, we're going to replace it with all of f of x. So instead of writing x squared, we're going to write x squared plus x squared. And instead of writing an x, we're going to rewrite it as x squared plus x. So now we just need to simplify. So once again, this x squared plus x, we could rewrite that as x squared plus x times x squared plus x. And then we've got this plus x squared plus x. So let's go ahead and FOIL these two terms. So we'll get x squared times x squared, that's x to the 4th. X squared times x, that's x to the 3rd. So we'll say plus x to the 3rd. Plus x times x squared, that's x to the 3rd. Plus x times x, that's plus x squared. And then we've still got this plus x squared plus x. So now let's combine like terms. So we have an x to the 4th, x to the 3rd plus x to the 3rd, that's 2x to the 3rd, plus x squared, that's 2x squared, plus We just have the single x at the end. So that is our final answer. That is f of f. All right, let's try another example. Let's say we have f of x is equal to 2x minus 3 and g of x is equal to x cubed plus 1. Let's say we wanted to evaluate f of g evaluated at the point x is equal to 3. So how would we do that? Well, we can rewrite it as f of g of 3. So the way that we solve this is we first plug in the value 3 for x in our g of x equation. So we can write 3, instead of x cubed plus 1, we can write 3 cubed plus 1. So 3 cubed, that's 3 times 3 times 3, that's 27, plus 1 is 28. So that is what g of 3 is equal to. But remember, this is all inside the function f. So now we need to plug in 28 into f. So we'll get, let's write f of 28 is equal to, so we'll plug into 28 for x. So that would be 2 times 28 minus 3. 2 times 28, that is 56. Yes, 56 minus 3. So we get 53. So that's our final answer. That is f of g evaluated at 3. Now, suppose we wanted to do, let's say, g of f evaluated at 4. Well, we could rewrite that as g of f of 4. So now we'll start by plugging in a 4 for the value x into our f of x equation. So instead of 2x minus 3, we'll have 2 times 4 minus 3. So 2 times 4, that is 8. 8 minus 3 is 5. So now f of 4 is equal to 5. So now what we can do is evaluate g of 5. So we're going to plug in a 5 every time we see an x in this g of x equation. So instead of x cubed plus 1, we'll have 5 cubed plus 1. So 5 cubed, that's 5 times 5 times 5. So 5 times 5 is 25, and 25 times 5 is 125. So 125 plus 1, that's 126. And that is g of f of 4. Thanks for watching.